Hey there, ever stop and wonder what this stuff in your kitchen, your cleaning cabinet, and get this, even your own stomach has in common? Well, today we're going to uncover the secret chemical world that's literally all around us. We're talking about acids, bases, and salts. So let's start decoding their chemical secrets, shall we? Yeah, just think about it for a second. Lemon juice, soap, seawater, they seem totally different, right? But believe it or not, they all belong to this secret chemical family. And that's what this is all about. We're going to go on a little journey to figure out their true identities. You see, it turns out that almost every single substance you can think of can be sorted into one of just three fundamental groups: acids, bases, or salts. It really just comes down to their chemical nature and, crucially, how they act when they're in water. Okay, so let's dive into our first family, the acids. Now, I'm sure you've heard of them, but what really makes something an acid? Well, in the chemistry world, they've got a cool nickname. They're known as the proton givers. So what does that really mean? Well, basically, an acid is just a substance that lets go of hydrogen ions. We call them H+ ions whenever it's dissolved in water. These tiny little particles, they're the signature move, the calling card of every single acid out there. And acids are everywhere. They range from the super strong stuff like hydrochloric acid, yeah, that's actually what's in your stomach helping you digest, all the way to the weaker ones we use every day, like acetic acid in vinegar or citric acid, which you'll find in lemons and oranges. So acids have this really distinct personality, you could say. First off, they're famously sour. Just think of biting into a lemon. And a classic chemistry test? Litmus paper. Acids will always turn blue litmus paper red. Plus, they can conduct electricity in a solution and even react with some metals to produce hydrogen gas. All right, now for every hero, there's got to be a rival, right? Well, in chemistry, the opposing force to an acid is a base. They're basically the other side of the chemical coin. So if acids are all about releasing those hydrogen ions, bases are their perfect counterpart. A base is a substance that produces hydroxide ions. We're talking OH- particles when it's dissolved in water. And yep, just like acids, bases are all over the place. You've got super strong ones like sodium hydroxide, which is used in powerful drain cleaners. But you also find weaker bases in everyday things like N-acids, that's magnesium hydroxide, or in a lot of common household cleaners. The personality of a base, it's pretty much a mirror image of an acid's. Instead of sour, they're bitter. And they have this really unique soapy, slippery feel, which makes sense because, well, soap is a base. And in that litmus test, they do the complete opposite. They turn red litmus paper blue. So here's a quick side-by-side that just lays it all out perfectly. Acids, they produce H+ ions, taste sour, turn litmus red. Bases, they produce OH- ions, taste bitter, feel soapy, and turn litmus blue. See? Totally two sides of the same coin. So the big question is, what happens when these two opposites finally meet? Well, you get this amazing chemical reaction that's all about finding balance and creating something brand new. It's called a neutralisation reaction. And honestly, it's beautifully simple. Check it out. You take an acid, like hydrochloric acid, and you add a base, like sodium hydroxide. What happens? They react, they neutralize each other, and they end up producing just two things: a salt, in this specific case, good old table salt, and plain water. That's it. And boom, just like that, this reaction brings us to our third chemical family, salts. And no, we're not just talking about the stuff you put on your fries. In chemistry, a salt is the stable compound that's formed when an acid and a base totally cancel each other out. It's like the official chemical peace treaty between them. Okay, so this is great. We can tell if something's an acid or a base. But how strong is it? Is it a really strong acid, like the stuff in a car battery, or a pretty weak one, like what you'd find in your morning coffee? How do we actually measure that strength? Well, the answer is something called the pH scale. The best way to think about it is like the ultimate chemical decoder. It's a simple ruler for measuring exactly how acidic or how basic a solution is. So here's how it works. The scale runs from 0 all the way to 14. Anything below a 7 is considered acidic, and the lower the number, the stronger that acid is. Anything above a 7 is basic, sometimes called alkaline. And what about 7 itself? Well, right in the middle, a perfect 7 is completely neutral. That's the pH of pure water. So let's put that into perspective. When we talk about something like lemon juice, we're looking at a pH of around 2. That's pretty acidic, and it's exactly what gives it that sharp, sour taste. Then you have pure water, sitting right there in the middle at a perfectly balanced neutral 7. And finally, something like a common bar of soap has a pH of around 9, putting it squarely in the mildly basic range, which totally explains its slippery feel and why it's so good at cleaning. Okay, so we've covered a lot of the science here, but let's bring it all back home. Why does any of this actually matter in our day-to-day lives? Well, the simple answer is it matters everywhere. I mean, this chemistry is constantly at work all around us. That strong acid in your stomach, it's digesting your food right now. If you ever get heartburn, you take an antacid, which is a base, to neutralize that stomach acid. The soaps and detergents you use for cleaning are bases, and so many of the foods we love, from fruits to salad dressing, get their distinct flavor from acids. Really, what this all comes down to is that from the moment you wake up to the moment you go to sleep, you are completely surrounded by this constant chemical balancing act. It's happening inside your body and all around you, all the time. So now you're in on the secret. You know the identities of these chemicals in your world. The only question left is, as you go about your day-to-day, what chemistry are you going to spot in action? Thanks so much for joining me.